Yeah, hi there. In this tutorial, we are going to cover ggplot2, which is a visualization package in R. It is based on the grammar of graphics. So the grammar of graphics basically uses the principle of constructing the figures out of different visual elements, and it uses the layered approach to build the graphs. So it's like different layers are accumulated one top of the other, and finally the graph is built up. So we'll just cover some basics of uh, ggplot2 ggplot2 library with some very basic charts in this particular tutorial. So our version I'm using is 3.6.1. I am installing ggplot2 dplyr and gapminder. In case if you don't have install, you can install it using install.packages, or other alternate ways. You go to the tools and do install package, and you can install these packages. So ggplot2 is for visualization, dplyr is to perform the functions like aggregate, etc., and gapminder actually is for the data. So once these package are installed, we need to load these packages using library. So I'm just loading these three. So just a quick reminder what gapminder is. So gapminder package actually it provides data related to the life expectancy, GDP per capita, population of different countries of the continents, starting from 1952 to 2007 at a gap of every 5 years. So this is so if I want to see what are the different unique years present in this gapminder dataset, I can say unique gapminder.year. It will tell, okay, this contains data from 1952 to 2007 at a gap of 5 years. So I'm just filtering out the data from gapminder. I'm not selecting continent Oceania, and whatever rest is there, I'm just capturing it in another data frame gap. So this is fine. And again, I'm just filtering this gap data frame and filtering it for a specific year 2007, so that gap underscore 2007 contains data related to only 2007 year. Okay, and now we can quickly check the structure of this data frame using str function. So if I see the str function, we see first of all at the top that there are 140 observations and there are 6 variables. So 140 rows and 6 columns. So what are these 6 columns? One is the country. So in country we'll have the name of the country, continent to which a particular country belongs to, year. So these year will be 2007 because I filtered for 2007. Life expectancy in that particular year, and population in that particular year in that country, and GDP per capita in 2007 for that given country. So this is what we have our data set. Now let's start with our first plot, which is a scatter plot. So scatter plot is used to find out the relationship between the two variables. So how do we create a scatter plot in R? We use the function ggplot. The first thing that we specify is the data is coming from where. So I'll say data equals to the name of the data frame, which is gap underscore 2007. Then we have to specify the mapping. So mapping is specified using AES, which represent aesthetic. So aesthetic basically represents which columns of a given data frame are represented on the chart. So on the x-axis, I want GDP per capita, and on the y-axis, I want life expectancy to appear. So this is what we am specifying in aesthetic function. And then I'm adding using plus, I'm adding geom underscore point. So this plus that you see, it's like adding layers to it. So this is the first base. Now after this, I want to add another thing is geom underscore point. So if I just use this and plot, I'll get output like this. So on the x-axis, what we mentioned is GDP per capita. On the y-axis is the life expectancy, and I'm getting all these data points. This is the base plot. Now on top of it, I'm adding another layer with plus. So this layer contains additional code which actually specifies the x-axis and the y-axis value, title, subtitle using this labs function. So if I execute, select all this and I execute, so I'm basically using RStudio. Uh, I'll just execute using run, and this is what I get the chart. Now this time I've added the title, subtitle, X and the Y axis label. So this is what is coming, what I added. per capita GDP, life expectancy. The title is per capita GDP versus life expectancy. This is the title, and the subtitle is year 2007. And this is our scatter plot, which shows the relationship between these two variables. Uh, One thing we can do in ggplot is we can capture a particular piece of code into an object. So let's say I want to capture this labs section where I've specified the x-axis and y-axis title subtitle into an object called as t, uh, kind of a, you can say, title. So wherever I need to represent these title things, I will just simply use t. So next I'm again doing a scatter plot. This time what I'm doing is ggplot. Name of the data frame gap underscore 2007. Mapping is on the x-axis again GDP per capita, y-axis is life expectancy. Now the points that I was getting earlier were all black in color. Now I want those points to be colored based on the continent, and then after that these this title to be this t objects to be applied, that is which contains x-axis, y-axis, title and subtitle values. So if I select all these things and I execute it, this is what we will get. So rest of the things are same like in the previous chart. The only difference is this time we specified in geom underscore point aesthetic color equals to continent. That is, we want to color these points based on the continent. So if you see, this is continent which is coming, Africa, America, Asia, and Europe, and based on these colors, you can quickly identify, okay, this data belongs to Africa, and then these blue points belong to Asia, and so on. So in this way, we can color the data points belonging to a specific continent or any other variable we want to. The next is again the same scatter plot I'm doing. Now this time, the only difference is I'm along with the continent, I'm specifying the size. Let's say I want these the circles that were coming earlier. It should be sized based on the population of country. So again, ggplot data is from the data frame. In the mapping, we have to specify the aesthetic, which is x-axis is GDP per capita, y-axis is life expectancy. Now this should be added to geom underscore point. In geom underscore point, we have to specify another aesthetics like what color we want. So color should be based on the continent and size should be based on this population. So if I and plus t means whatever x-axis, y-axis, titles, etc. that we had created earlier, that object will be applied on top of it. So if I run this, what I'll get is this. So if you see this time in the legends, we are getting the different colors of the dots. For that different colors, we are getting continent. Now, if you see the size of this of the circles, it is varying. It is varying based on the population of the country. So the higher the population, the bigger the dot. The smaller the population, the smaller the dot. And this is what the range of population is giving here. Now we can add another dimension is by changing the shape of these data points. So rest of the things are same, just data coming from the same data frame. X-axis, Y-axis are same, GDP per capita and life expectancy. The color is based on the continent. And now I want the shape of the data points should also change. It should not be circle for all. It should vary based on the continent. That is, for a different continent, there should be different shape. So if I run it, what I'll get is this chart. So if you see, there are in this legend. So for circles, it is red circle. It represents Africa. For this green triangle represents America, and blue rectangle represents Asia. So we are getting different color as well as different shape because this is what we had specified in geom underscore point, color as well as shape to be based on the continent. Okay, so continuing further, we are now going to cover bar chart. So uh, bar plot basically in R uh, it gives the count for the different categories. Let's say I want to count how many countries are there in a given continent. uh, this for this data frame gap 2007. So I'll say ggplot, name of the data frame. In the aesthetic, I want on the x-axis, I want the continent, and I'm just saying plus geo underscore bar. So if I just execute this much portion of the code, so I'll get this output. So this is the bar plot. So for this different continents, America, Africa, America, Asia, Europe, on the y-axis I'm getting the count. So it means Africa had around 50 plus countries, America had around uh, mm, that many, Asia had around that many countries, and so on. So basically, in the bar plot in R actually does the counting. Along with this, I can specify the title, x-axis, and the y-axis values based on these labs values. So if I execute this together, I'll get a slightly better plot than earlier. So I'm getting title, y-axis, x-axis values, whatever I specified in the labs function. And now let's say I'm calculating the mean population of continents in 2007. So I'm just doing gap underscore 2007 group by continent. And the summarize, I'm calculating the mean population, sorry, median population, and adding and storing the result in this another data frame, median population by continent. If I just print this particular value, if you see, you will get continent name and the median population. So for Africa, this is the median population. For America, this is the median population. Now I want to plot this in the bar plot. So in ggplot, I will specify the data frame. This is the data frame in which I stored the result. On the x-axis, I want continent. So I'll give x equals to continent. Now y equals to median population. So one thing you will notice in the previous case, we did not specify anything in the for y-axis in bar plot. So by default, bar plot in R actually does the counting. So we don't, if we want this default behavior, then we don't have to specify anything in the y-axis. Otherwise, if we want to specify anything else apart from the count, then we have to give that value. So what I'm giving here is on the x-axis should be the continent, on the y-axis should be represented by this median population, and the only thing I have to change now is in the geom underscore bar I have to say stat equals to identity. So it means identity means pick the value as specified in the y-axis instead of doing the count, and then I'm just setting the title x-axis and the y-axis labels. So if I run this in the output, I'll get the median population of continents in 2007. That's the title. On the y-axis, we are getting the median population. X-axis, we are getting the different continents. Okay, continuing further, let's say I want to extract data for a given country from our initial data frame gap. So I'm just saying gap, and I'm just filtering based on the country India and storing it in India underscore df data frame. Now I want to plot how the population growth happened in India over this period. So what I have to do is in the ggplot, data is coming from this ind underscore df data frame. On the x-axis, I would want year, and on the y-axis, I want the population. So this is what we have to specify in mapping aesthetic. So mapping equals to AES, which represents aesthetic. X-axis represents the year. Y-axis should have population plus, that is which geometrical object I want, geom underscore line. So it will create the line. If I print only just this much, if I execute this much only, okay, I have to create this data frame first, ind underscore df, and I execute this much only, let's say. So what I'm getting is year, and so starting from 1950 to 2007, this is how the population of India actually grew in over this period of time. Now, apart from line, I also want points, so I'm adding one more layer using plus, and this another layer is geom underscore point. So this This is another geometric object that will appear. That is, apart from line, I want points also, data points also, dots also to come on this. And then I'm just setting title, subtitle, etc. And I'm storing all this thing in the variable small g. So this is done. Now, if I want to see that particular chart, I can do print small g, that is the object in which I stored, and in the output, I'll get like this. On the ER population, title is population growth in India, the subtitle is from 1950 to 2007. In the caption, I'm getting source equals to gapminder package. This is the caption I'm specified. Year is this x-axis and the y-axis is the population. So I'm getting line as well as point. So these are the two layers that we added. To save this particular graph, what we have to do is we just have to call ggSave function and specify name of the file with which we want to save. Let's say plot.png or any other meaningful name, and which plot to save. This plot actually was stored in g small g object, so I'm saying plot equals to small g, and then we can also specify the height and the width of the file. So if I just say height is 6 and width is 8, then the file would be saved with this particular name, and it will have plot which was specified as a small g object. Okay, continuing further, we'll cover histogram. Histogram basically it's a frequency distribution uh, chart. So let's say I want to see what is the frequency distribution of life expectancy for the year 2007 for all the countries across the continents. So what I have to do is ggplot and name of the data frame from where the values should come, and within the aesthetic I want to use this column life expectancy. This is the column on which for which I want the histogram to be built. So after specifying plus, I have to specify which geom to be used. It is histogram. So I'll say geom underscore histogram. Now, at the time of specifying the histogram, we can specify the bins, how many bins I want to, under how many bins the data should be created. So I have specified 20, so 20 bins will be created in the chart, and these bins will be, these bars basically will be filled with blue color, and so fill color is the blue inside the color of the bar, and this color white is will be the outside color, that is the color of the edges. Then I'm setting title x and the y-axis labels using this labs function. If I print this, if I execute this, I get this histogram which says the life expectancy in years, and the x-axis, y-axis is the frequency. This is the title frequency distribution of life expectancy in 2007. So this is the histogram that I got. So we specified bins equals to 20. So overall there are 20 bins. So what it means, if I see between 70 to let's say 75, uh, that was the frequency which is represented by the y-axis. So for any given bin, uh, we can actually find out what was the frequency of data points which were falling within that bin by looking at the corresponding y-axis. That's it for now in the session. Thank you.